I'm going to walk you through the keyword spotting's initialization step. Remember that the keyword spotting application has got many different components to it, going from initialization into the main loop. Now, the initialization, which is the first step, has got many subcomponents. Don't be alarmed by the large number of steps we have to take. I'm going to walk you through each and every single one of these in greater detail. The most important thing to take away from this slide is that these are the steps we're going to be doing regardless of what application you are building. Let's get started. The very first step is to simply declare the variables. Specifically, you want to declare the variables that correspond to TF light. For example, that you need an error report, that there's a model pointer, that there's a pointer to the micro interpreter, and so forth. These will tend to happen regardless of the application you are building. The second portion really focuses on the tensor arena. Now, remember, you have to experimentally determine how big a tensor arena you're going to have. Bigger is always okay from the execution standpoint, as long as the model fits. Now, remember, if you have to make the tensor arena too big, then you're effectively wasting space, and which might not be needing at all. So you want to try and figure out what's the minimum amount of the tensor arena size that you really want, and then allocate that as an array that actually holds that space. After that comes loading the model, which you can do using the get model function, which takes a pointer called g_model. G_model is nothing but a pointer to an array that actually contains a hexadecimal dump of the actual neural network that we are using. In our case, it's a tiny conv network, which is effectively expressed here in a raw format. Now, the key thing to remember here is that you could always use the all ops resolver and include the library with all the TF ops. But you don't want to do that because you want to keep the amount of binary space that's occupied by TF micro as an executable. You want to keep that small. And you can do that only by bringing in the ops that you are using in the actual neural network that you are deploying over here, which in our case is the depth-wise, conv2D, fully connected, softmax, and reshape. And that allows us to only use the code that's needed for actually executing the neural network. Now that we have all the bits and pieces, we can actually instantiate the interpreter, which we are doing here by passing in the model, the micro-op resolver, the tensor arena, the size of the tensor arena, and the error reporter. Once we are done with that, we can actually allocate the memory for the tensor arena, where the model is actually going to be executing out of. Next comes actually defining the model inputs. Now, remember, you're going to have your input audio data coming from some space. And you're going to get that processed through a couple of stages. And then it needs to be handed off to the interpreter, which is actually going to run the input through the network. So you have to link the two things together. And the first thing you do here is actually figure out where's the interpreter input coming from. And then you express that by making the connection to model_input. The key takeaway here is that you need to be able to link the input that the model is going to be getting to actually input the actual input that you are going to be providing it with. Now that we have effectively set up everything that we need for TensorFlow Lite Micro itself, we can set up the other parts that are relevant to our application, such as the feature provider and the recognize commands. Feature provider is the one that, in keyword spotting will generate the spectrograms. Recognize command is one that will actually do something based on the words that it might recognize, such as a yes or a no. All that said, we walked you through these steps, from declaring the variables down, to the setup of the main loop. Now, remember again, the takeaway here is that all these are general steps that you're going to be following regardless of the application. All that said, in the future slides, I'm going to be using initialize interpreter to refer to many of these steps above, because these are the things that we will be doing repeatedly. So keep that in mind.